Dear students, in this session, let us know about the cardinal points in a thick lens. These are the fundamental things we have discussed in the previous sessions about the cardinal points, to principal points, to focal points, to nodal points, and also about the Cartesian sign conventions. What is a thick lens? A thick lens is a large lens whose spherical surfaces are separated by a distance which cannot be neglected when compared to the radii of curvature of the spherical surfaces. Or else, in a simplest way, it is a lens whose thickness cannot be as small as compared to its focal length. Considering a thick lens here, let OA be the incident light on the thick lens on the first surface here. It gets refracted at a point A and takes the path AB, and refracting at this point B, it gets refracted and takes the path BF2. And this ray OA is extended in the forward direction, and this BF2 emergent ray is extended in the reverse direction. These two meet at a point H2, and the line joining this point H2 and the point on the principal axis perpendicular to the principal axis is called as second principal plane, and the point on the principal axis is called as second principal point. And similarly, when the light ray is incident parallel to the principal axis here, the emergent ray will definitely pass through the focal point. Hence, this F2 is called as second focal point. Similarly, when a light ray is incident from this end, it gets refracted, takes the path TS, and at this point it gets refracted and takes the path SF1. And in this incident light and emergent light are extended, this in forward direction and this emergent light in reverse direction. These two meet at a point H1, and this point and the line joining this point and the point on the principal axis is called as first principal plane, and this point is called as first principal point. Yes, definitely. Similarly, when the light ray is incident parallel to the principal axis here, the emergent ray will definitely pass through the focal point F1. This is called as first focal point. Now, finding the equivalent focal length, expression for the equivalent focal length of the thick lens. Looking at this diagram, let P1 F1 be equal to F1. P1 F1 is focal point here, minus, definitely it should be minus, and this P2 F2 is plus, this is plus, but F2 is equal to F1. Naturally, quite naturally, in a normal way, we write it as F. In the previous sessions, we had come across an equation, refraction at the spherical surface. There we had come across an equation that is mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Now, applying the same formula to this surface, we write this like this: mu by V1 minus 1 by infinity, because U is at infinity. Since this light is incident parallel to this is equal to mu minus 1 by R1, or else on rearranging we get this equation. Similarly, applying to the second refracting surface, we get this equation: 1 by dF2 minus mu by di is equal to mu minus 1 by minus R2. In fact, this has to be written as 1 minus mu, but instead if we rewrite it as mu minus 1, it should be taken as minus R2 here. Now, from this diagram, H2, P2, F2 and GDF2, these two are similar. Similarly, BCI and GDI are also similar. Based on those comparisons, we have this equation here: 1 by F is equal to 1 by dF2 into di by V2. Now, on multiplying equation 2 by di, we get this equation 4. Now, on substituting equation 4 in 3, we get this equation. right? And knowing all these parameters, since CD is nothing but the thickness of the lens, and the DI is nothing but DI is nothing but DI, this DI is nothing but CI minus CD, CI minus CD, and CI is nothing but the first image, that is the image formed due to the first surface only. Therefore, substituting all these parameters in this equation, we get 1 by f is equal to mu by v1 minus mu minus 1 by r2 plus mu minus 1 by r2 into t by v1. Now here we have 1 by v1 terms on RHS. See here, equation 1, substituting this 1 by v1 equation in this equation 6, we get, and on simplification we get this equation 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2 plus mu minus 1 into t by mu into r1 r2. This is an equivalent focal length in case of a thick lens, and this is what we have come across in this session, and these are the references I have made use in defining all these terms in this session. Thank you for watching this video.